Okay, anything I can go over these two? I can handle it. Luke? What'd you say?
110.
110. 110. Okay, let's take a look at 110. Page 472. Our half-life of aspirin, okay, in the blood is 12 hours. Estimate the time required for the aspirin to decay to 90% of the original amount ingested. All right, obviously we got 1.82 hours. Let's take a look at this here. 110. And let's do A of t equals A sub 0 e to the kt. Now, one thing they don't do is they don't give us an amount, right? They don't say 10 grams, they don't say 50 milligrams, they don't give us an amount, but they give us enough that we can figure this out. The half-life is 12 hours. Okay, so half-life. What is it? 12 hours. What that means is, well, no matter what you put, if this is 20, this will be 10. If your original amount's 50, it'll be 25. And when you divide, you're just going to end up with a half over here. Equals e to the kt. Well, t will be 12 hours. So I'll get 1/2 equals e to the 12k. Before we can do this, we're going to have to find k. We're going to have to find k. And so we got enough information to find k. Now, key step here, we've been doing this for several of them. Natural log of 1/2 equals 12k. Divide by 12. And then I get k equals natural log of 1/2 over 12. Now, we had that formula from yesterday. I think the formula from yesterday was h equals negative natural log of 2 over k, right? Well, if we know h, if I multiply both sides by k and divide by h, you can end up getting k equals negative natural log of 2 over h. Those are going to be equivalent. So you can use that. I know h, it's going to end up equaling this. Well, we said natural log of 1/2 is the same as negative natural log of 2. You can leave this. I really don't, it doesn't matter. But this will be k. Well, now we go back, and what do they want to know? How much is left? What is it? 90%. All right, how do I do that? So 50% is, you just make it a half. If you want to know what 90% is, well, I'm just going to make something up. So you start with 10, you're going to be left with 9. Okay? If you start with 20, we're going to be left with what? 18. What happens when you divide by 10 and what happens when you divide by 20? What are you going to be left with on the other side? 0.9. So really, we're just going to have 0.9 equals. So even though they don't give us an amount to start with, it doesn't matter. They say when is 90% left is going to be that. 0.09 equals e to the kt. We're going to use that value for k we got down here. So natural log of 0.9 equals kt. Divide by k. And so now t equals natural log of 0.9 over k. So it doesn't matter which one you use. So natural log of 1/2 over 12. All right, make sure that's 1.82. Dude, if you didn't get it originally, I'm going to pull up my calculator here real quick. Type it in. Make sure you get that case there. Let's see, is it popping up? Yep. All right, so we got natural log of ln 0.9. and you can type it all on at once, or you can go step by step. Equals that divided by, and then I got to do natural log of 1/2, which is natural log of 0.5, ln of 0.5. Whoops, I didn't hit divided by. Divided by parentheses. Let's see here. I think I can do this. Natural log of 0.5, close my parentheses, divided by 12, close the whole denominator. All right, 1.82. Okay, so just make sure you can get that. All right, so that's 110. Okay, for that one. All right, we need to continue with the exponential, and then we're going to get into some of the log equations here. Like I said, finish a little bit up tomorrow. Spend most of the time reviewing, and then review as well on Monday. Test. And I'll give you a little bit more information here. Not as many sections as some of the other ones, though, which is good. All right, let's take a look at this one here. Copy that one down. Okay, yesterday, the last problem we did was 4 to the x equals 100. And we said, all right, let's take the log of both sides. What you want to do is, if you can, is you want to get this whatever's to the power by itself. So I want to move, and since that's just a 20 over there, I'm going to divide by 8. Okay, before I do, you can take the log of both sides here, but it gets just a little messier. So I'm going to divide by 8. And then I get 3 to the x minus 2 equals 20 divided by 8, 2.5, 5 halves. Okay. As long as it's a terminating decimal, you can write that. You cannot round off a decimal, so it's like 0.3 repeating. Make sure you leave that in terms of a fraction. All right, now you either take the ln or the log of both sides. Now, on that second one from that assignment, you had an expression in the power. The power comes out in front. So this becomes x minus 2 times log of 3 equals log of 2.5. You got two options. You can distribute the log of 3 to both of those, but in this case, I can get away without doing that. Okay. I'm going to divide both sides by the log of 3. And that will give me x. Now I can just write x minus 2 equals log of 2.5 divided by log of 3. And that'll give us some decimal, but I'm just going to wait. Add 2 to both sides. Use your calculator. Figure that out. Add 2. Round it to the nearest thousands. We're going to go 3 decimal places for all these. So I get x equals log of 2.5 divided by log of 3 plus 2. And then substitute that in. Brooklyn, let me know what you get nearest thousands. Oh, don't have that calculator out. All right. I'll go. Kate, let me know what you get to the nearest thousands.
2.834.
2.834. Now what I'm going to do is I'm just going to do a quick check to see if that looks approximate. So I'm going to plug it in. I'm going to plug it in first. So I got 8 times 3 to the 2.834. I need a private parenthesis here. And then minus 2. All right, 19.99999. It's not going to be exactly 20 because we round it off. So that lets me know I'm correct. So we're good. So 2.834, plug that in, gives me close to 20. All right. These can get a little complicated. Okay. Now I got a variable on two separate, exponents on two different ones. For that last one, we divided by 8, so you can move anything around. Here, you cannot do that. Okay, you got 4 to this power, you got 3 to this power. Okay, so now, once we have things isolated, we're going to go ahead and take the log of both sides. So I'm going to write the log of 4 to the 2x plus 1 equals the log of 3 to the x minus 2. Move the exponent out in front. 2x plus 1 times log of 4 equals x minus 2 times log of 3. Okay. Okay, now we can't, dividing by the log of 4 or dividing by the log of 3 doesn't really help us. You could, but it doesn't get you to a point where it's that easy. Log of 4 is a constant. All right, so what I mean by that is think of that as 2x plus 1. Log of 4 is like the number 5. And x minus 2 times log of 3, and make that an 8. Those are constants. Well, what do we do with a constant with a set of parentheses? We do what? Distribute it. We're going to distribute the log of 4. You just got to watch how you write that. So log of 4 times 2x is going to be, probably easiest way I write it is just 2x log of 4. Log of 4 times 1 is just log of 4. X times log of 3 is x log of 3 minus 2 log of 3. All right, how many terms do we have total? 4. You have, how many terms have an x? 2 of them. We're going back to just your rules for solving an equation. Get everything with an x on the same side, everything without on the other. And it doesn't matter which side, that'll affect how your work looks a little bit. Whoops, I don't want that one. This one right here, this one right here, both have an x. Okay, so I need to move this one over. Let's see here. Here's what I'm going to do. I like to get as few as negatives as possible. So I'm going to keep the log of 4 over here. I'm adding 2 log of 3 to both sides, plus 2 log of 3 equals x log of 3. Now I got to subtract minus 2x log of 4. So I got everything with an x on one side, everything on the other. Now log of 4 plus 2 log of 3 equals. All right, our own rules. If you got 2 terms with an x in it, you factor out the x. Now, what's that going to look like? Everything's being multiplied in each of those terms. Factor out the x. Okay, you're basically dividing each piece by x. It's going to be log of 3 minus 2 log of 4. All right, what do you do at that point? Alex, what do you think?
I have no idea.
In an equation, the whole goal is to get what by itself?
X.
So I got this x. What's going on with this x in this whole quantity?
Could you divide it by log of minus 2 log of 4?
Yep, we're going to divide by that whole thing. Yep. So we're going to divide by log of 3 minus 2 log of 4. So we're going to divide by log of 3 minus 2 log of 4. I'm just going to change the order and put the x first. So x equals log of 4 plus 2 log of 3 over log of 3 minus 2 log of 4. Okay, now it's just a calculator entry problem. You can think of the numerator in parentheses, the denominator in parentheses. You can go bit by bit. Don't round off to the very end. All right, see what you get. Round to the nearest thousands. Round to the nearest thousands. Now, if you want to check it, you can plug it back in and see if the two sides are pretty close. All right. Okay. Brian, you got an answer yet?
No.
Not yet. All right. Brooklyn, now you got an answer?
Negative 2.141.
All right. I've seen that the most. X equals negative 2.141. I believe that's right. Watching your entry stuff. If you're not getting it, then let me know. All right. Now, this is what we call the approximate answer. It is approximate because it's rounded off. We're going to do a little bit of simplifying here and get the exact answer, okay? Or a simplified version. All right, what I want to do is now let's take the top and let's use our exponent rules and write it as a single log. So I want to write, so for the exact answer, we're going to write the numerator as a single log and the denominator as a single log. We're going to condense it. So we also want the exact answer for this case here. So for the exact answer, write the numerator and denominator as a single log. Okay, and I'm going to ask you for both answers at times. So the times I just say give me the decimal, times I'll say give me both. So I'm starting with x equals log of 4 plus 2 log of 3 over log of 3 minus 2 log of 4. All right, how do I condense? This is basically a condensed problem. How do I condense the top? Is you take a single log. If there's a plus, you write it as a multiplication. If there's a minus, it's a division. And if you got a number in front, it becomes a power. So what happens to this 2 here? It becomes a power here. What happens to this 2 here? It becomes a power. So I get the log of 4 plus log of 3 squared, which, yes, is 9. And I get the log of 3 minus log of 4 squared. All right, this will become on top the log of what? When I'm done. 5 is making sense? What's it going to equal?
3 times 4.
Not 3. 3 squared, which is
9.
9 times 4, which is,
36.
so it's going to be log of 36. So I'm taking, I probably could have written another step and made that a 9, but I'm going to do that. Leave that. All right, this one's going to come out as a fraction. That's okay. We're going to divide 3 by what? 16? So it becomes what on the bottom? Log of 3/16. This right here is the exact form. So x equals log of 36 over log of 3/16. So this is exact. Okay. So now log 36 divided by log 3/16 negative 2.141. Now, which one's easier to type in your calculator? I mean, I know this is key thing is you got to watch you don't make a mistake going from this format down to this format. Because you make a mistake, then you're going to think your answer's right, and it'll obviously it'll be incorrect. So you got exact, you got approximate. Okay, exact and you got approximate. All right, so yeah, these get messy. We go. Right. Now I throw a constant out in front. This one, these are not short problems. So like, if you got like 2 lines on your piece of paper, that won't work really well. All right, 5 times 4 to the x plus 3. First thing you got to ask at any time is on the last one, not the last one, but the one before, you had the 8 out in front. We divided by 8 because 20 divided by 8 was 2.5. They kind of got it out of the way. That worked out pretty good. For here, will it benefit us to divide by 5? Okay. Because you got to take a look at that other side. That other side has a constant with a power. You cannot divide it by 5. It's not going to help because it's still 6 over x. It's not going to reduce. So I got to leave the 5 there. So we're going to take the log of both sides. So I got the log of 5 times 4 to the x plus 3 equals the log of 6 to the x. Now you got to watch here. This is a little complex expression we're taking the log of. There's a product in there, 5 times that. So since there's a product in there, you have to split it up as a sum, and it becomes the log of 5 plus the log of 4 to the x plus 3. Over here, log of 6 to the x. I can put the x out in front. I'm going to have to eventually, so x log of 6. Now, we split it up. You got to watch. This x plus 3 only goes in front of the log of 4. This log of 5 is separate. So I got log of 5 plus x plus 3 times log of 4 equals x times log of 6. Okay, I got x plus 3 times log of 4 right here. I got to distribute that log of 4 in. So I'm going to end up with log of 5, that doesn't change, plus x times log of 4, plus 3 times log of 4, equals x times log of 6. All right, everything with an x on one side, everything out without an x on the other. All right, so just take a look and think, all right, what are you going to move? Now remember, I got 1, 2, 3, I got 4 terms. I do have an x with this term. I only got 1 x over here. I'm going to just subtract that, minus x log of 4. Let me get rid of these. Minus x log of 4. So I get log of 5 plus 3 log of 4 equals x log of 6 minus x log of 4. Okay, I got 2 terms with an x, factor out an x. So move that out in front, and then you're going to divide by what's left. Okay, so you can move forward there. So I got log of 5 plus 3 log of 4 equals x times log of 6 minus log of 4. Now to get the approximate answer, to get the decimal answer, I can right here divide by log of 6 minus log of 4. So I end up with, I'm just going to flip the order here. So I get x equals log of 5 plus 3 log of 4 over log of 6 minus log of 4. So got that. You can type that in your calculator now, get the decimal. You can reduce it to the exact and then get the decimal after that. I'm going to ask you for both. I want the approximate, I want the exact. Okay, so we need them both. If you want to try and write it as the exact first and then do that, that's fine. I'll do it here in a second. Or you can come up with the approximate. All right. See what you get for your decimal. Compare it to whoever's sitting beside you. See if you get the same thing. You feel good. What you got? Right. Oh. That's also another cookie. What'd you guys get back there, John?
14.226.
Uh-oh. Which table's right? They got 2.418. Luke, what'd you get?
14.226.
Oh, I'm just hearing a lot of 14s. 14.226. So let me see here. Now I can do log of 5. Sometimes I don't like typing the whole thing in just because it's easy to make a mistake. Plus 3 log of 4. Okay, so that's the numerator divided by, now I got to make sure the entire denominator is in parentheses. Log of 6 minus log of 4 and 14.226. Both got the same thing on what you did. All right, so I got that. Now, all right, exact form. I want the exact form. So I'm going to start. So this is approximate because it's rounded off. Okay, so for the exact, I'm going to start with x equals log of 5 plus 3 log of 4 over log of 6 minus log of 4. All right, that becomes a power. That 3 in front, I only got one coefficient. And I'm just going to take maybe an extra step. I know a lot of you might just do some of this in your head. Absolutely fine, but just for notes, I'm going to write it out. All right, for this one, what's 4 cubed? 4 to the third power. Did I write that out right? Yeah, 64, right? So now this is really log of 5 plus log of 64 over log of 6 minus log of 4. So equals log of what? The numerator is going to equal log of what? What do I do with the 5 and 64? Multiply. What's 5 times 64? Is that 320? So 320. 6 over 4, divide. Now that works out to a nice number. What is it? 1.5. Or you can just reduce it, or I would ask you to at least reduce it. So log of 320 over log of 3/2. Now I didn't plug in my answer to see if it was right, but if I get this one the same, I got to be pretty confident. Log of 320 divided by log of 3/2. 14.226. All right, so we're good. Remember, you can also do the natural log of all of this instead of the regular log. So if I do natural log, it's still going to get the same thing. Okay, for that. This is exact. Exact. Know the difference. If I ask for the approximate answer or if I ask for the exact answer, know the difference. Okay, for some reason everybody gets those confused. That does not deal with any round off. All right, ladies, these get a little bit messy. You got to try and keep things straight, get everything with an X on one side, everything else on the other. Kind of our old rules. That's exponential equations. We do a couple here with what we call log equations. We're going to do the equation of log on one side first, and then we're going to save the others for tomorrow. I'll at least get through a couple here. Now, occasionally you'll come across one or two where you could look at it and kind of using your intuition kind of figure some things out, which is fine. But we could also solve these by taking the log equation and writing it as an exponential equation. If you isolate the log, use our log properties, and you can kind of go with your old swoop method to write it as exponential. So what's my base? 3. What's my exponent? 3. And what does that have to equal? X plus 2. 3 to the third power equals X plus 2. And so I get 27 equals X plus 2. Subtract 2, and you get X equals 25. All right, that doesn't come. You got to be careful. It doesn't come up in this problem, but it will come up in other ones. We can only take the log of positive numbers, right? If you get an answer back that gives you a negative number that you're taking the log of, you got to throw it out. Well, 25 plus 2 is 27, which is a positive. That's good. But you have to check these answers when you're plugging them into a log. All right, second one here, log base 3 of X plus log base 3 of X minus 2 equals 1. Cannot convert to exponential until you have a single log. Okay, cannot convert to an exponential until you have a single log. So now, there's a plus. They're the same base. So I can make this log base 3 of X times X minus 2 equals 1. Some of you say, can I multiply those together? Yeah, we'll eventually get there. I have a single log. I got the base converted to exponential form. Okay, converted to exponential form. So for exponential form, my base is 3. My power is that 1. You get your old swoop. 3 to the first power equals X times X minus 2. Well, we're solving for X. So that gives, I'm going to go ahead and distribute. I get 3 equals X squared minus 2X. All right, now don't forget, you got a quadratic. Okay, you want to set a quadratic equal to 0. So you get X squared minus 2X minus 3. Go ahead and factor. And I factor this into X minus 3 times X plus 1. So I get X equals 3. And I get X equals negative 1. All right, this is where you have to examine it. Well, I end up taking the log of a negative number when you substitute those back in. Yeah, because the first one is just X. And if X is negative 1, that's going to be a negative number, plus negative 1 minus 2 would be negative 3. That one has to be thrown out. You're going to get an answer of X equals 3. Okay, that'll be the last one. Now, you do test 3. 3 does give you positives, and then you want to test it to see if it's correct. But if it gives you a negative, you got to throw it out. All right, one last one we got to get through here. Okay, log base 2, x plus 7 minus log base 2, x minus 7 equals 3. If it's a minus, how do we condense it? We have to make it a division problem. So it's going to be log base 2 of x plus 7 over x minus 7 equals 3. Remember, you only have one log. Once you get this, you can convert it. So it gives me 2 to the third power equals x plus 7 over x minus 7. Now, every problem's a little bit different. Again, how you solve it. The last one, we ended up with a quadratic. We had to factor it. We're not going to end up with a quadratic here. 2 cubed is 8. All right, think about what you want to do here. I want to get rid of that fraction. I'm going to multiply both sides by that denominator. We'll get rid of, multiply by x minus 7. So I get 8x minus 56 equals x plus 7. And then I end up with subtract x. 7x minus 56 equals 7. Add 56, I get 63. It looks like I get x equals 9. Will that work? Go back to your top, the original equation. Will that give us a negative that we're taking the log of? I don't think so. Nope. 9 plus 7 works, and 9 minus 7 works. All right, so we're good. So x equals 9 is our answer. So this is where we got logs. Okay, the equation has a log in it. The ones before that are exponentials. You have to take the log of both sides. So two different things going on. Okay, for that. All right. So page 484. When we found the exact value, I want you to find the exact value for 40 and 41. Off of those. Okay, as well as the decimal. Okay, because I know that the answer in the back of the book will have the decimal. I also want you to be able to find the exact value.